Well, hello, my algebros. Here we go, looking at choosing a factoring method. And this is really just kind of wrapping up our chapter 7 of how to factor, right? And factor is the opposite of multiplying, right? We're looking at what are the things that factor to have something come together. So we're trying to figure out, are we factored completely? On number 1's example, we look at this and can you take a GCF out, or is there a difference of two squares? And the answer is no. So we would look at this and say no, there's no common factor, there's no difference of two squares. So this is factored fully or factored completely. On number 2, we have two binomials, and we look at this and you can see, oh, there's still a GCF here, so we can take out a 2. So now I know that's 2 times x plus 3 times x plus 5, and now it's factored completely or fully factored. Here we see that a 2 has been taken out, but there could have also been a y. So we go ahead and take this y out, and now this is factored completely, right? Okay, so we think about all those things. Let's talk about how we first always take a greatest common factor, and then we can look at recognizing other patterns, and we like to also call those specials, like a difference of two squares or a perfect trinomial. When I look at this example, I first think, oh no, I'm going to have to do AC method and multiply my -2 times -32 and find a factor in there. But instead, I could just take a GCF out, right? They all have -2 and they all have an X. And if more than half have a negative, you always want to take it out. And if you have two terms, you want to take out a negative to see if there's a hidden difference of two squares. But let's go ahead and take out this greatest common factor, and we get y squared minus -8y plus 16. And I see that this is a perfect trinomial, right? Because if I square root 16 and double it, I get 8, which is the middle term. If I can't see that, I can always Xbox it to have figured that out, right? I could always Xbox, put my 16 in there, and see if it's factorable. What are two numbers that multiply to be 8 and add to be multiply to be 16 and add to be -8? Well, it's -4 and -4. So now I know that it's factored completely. All right, so here's a two-termer, like I said before, and if this is a two-termer where you can get the middle term to have a negative, you always want to make sure you factor out the negative. So we're going to go ahead and take out a -3b here, because that leaves us with a difference of two squares, right? We want to see that hidden difference of two squares in there. And then we can factor that out with the shortcut of square rooting 9, square rooting a squared, and square rooting 4. Plus or minus, because they're difference of two squares, which means they're different or opposite twins, so that there's no middle term. All right, go ahead and do this. You try. See how you're doing on it. You can pause the video here, and then you can go ahead and check your solutions. All right, I'm going to go ahead and take out a 2y. I don't take out a negative because I want to keep the negative in the middle, right, like it is. And this way, I see that there's a difference of two squares. And now I factored completely, right? Sorry about this little extra writing there. Okay. All right. Filtering by multiple methods. Let's see. So when I start here, I always see if I want to take out a GCF. It just makes my life easier, right? I mean, obviously I could do AC method, but this is easier to take out a GCF of 3n squared. And then I end up with n squared minus 5n plus 4. And this is not a perfect trinomial. But I could always X box it to see that I would use -1 and -4, because a negative times a negative is +4, and a negative plus a negative is -5, right? So there we have it, our factors in there. So this way, we always start with the GCF and then see, do we have the X box? Is it a special? What is it? Okay, this is our last sample for today, and then the notes online have a little bit more examples if you need help with those. But let's just see about this one, because it's a lot of layers of things. So our GCF is P. We take out a P, and we get P to the 4th minus 1. Now, 1 is an interesting number because you can square root it infinite amount of times. So then it just comes to the exponent. Can I divide this in half, right? So P4 minus 1 is a difference of 2 squares, right? So we go ahead and split our P's and do the square root of 1 plus and minus. We do this, we see the second one, P squared minus 1, is another difference of 2 squares, right? So we need to factor that out. Now we have to remember to bring down all the other factors and then go ahead and factor out P squared minus 1. So this is our big long answer here, and it is factored completely. And on the test that we're going to be doing next week, you have to factor things out completely, right? So we'll go ahead and do some practice on this, and have a great day. Oh, you know what? I'll go ahead and run through these. But if you get it, you leave the video here and go ahead and start on your assignment. But if you want to do a few more extras with me, I'll do those with you. So let's check out this one. Let's take out a 2x squared. And we see it's x squared minus 25, which is you're right, difference of 2 squares, right? Okay. Go ahead and do this you try. Pause the video here and then check your solution. Okay, we took out a 2a out of here. And we get a to the 4th minus 16, which is a difference of 2 squares. And another difference of 2 squares. And there you have it. Now it's a big one. Let's try this one. Go ahead and try this and see what you get. All right. This is a 4-termer, right? So I want to, I'm personally going to reorganize it so that it's in standard form. And things are just a little easier to factor. On the first one, I'm going to take out 20a squared. And the second one, I'm going to take out a -5. And then I regroup. But I can still see I have a GCF I can take out of the first term, which then also leads me to a difference of 2 squares. Right? I really have to watch the GCF right in this step right there, because if I don't, then I won't get to that difference of 2 squares. Let's look at another way to do it. What if I decided at the beginning to take a greatest common factor out? If I divided the whole thing by 5, right? Then I have this polynomial to go ahead and factor completely. I do it by grouping. I take a GCF out. And when I take the GCF out, I can see, oh, thank you. I can see that it's a difference of 2 squares in there, right? So either way are great, but you can see that when you take that GCF out right here at the beginning, the numbers get easier to work with versus they're so large to work with. But it's really a matter of personal preference. Okay, here we go. You have an A and B practice worksheet that we're doing in class, and if we don't finish it, then it's homework. Have a great day.